Good day, folks. Welcome to my YouTube channel. If you're new here, please don't forget to subscribe. Don't watch my videos without subscribing, and like my videos, watch them till the end. Don't skip the ads. And thank you very much for your support. Today in lessons, we're going to look at electrodynamics. The electrodynamics, it's electric machines. We're going to look at two types of electric machine, but in this video, I'm going to look at the generators. The generators, as it says, is generating electricity. So when we talk about the generator, it converts the mechanical energy, which is when we talk about the mechanical energy, we're talking about the movement, and which is it's a mechanical to electrical. Like Eskom uses the generators, right? So they uses the mechanical to produce the electrical energy that we get in our houses. Now let's look at the two types of generators, guys. All the time, the energy conversion for a generator, it's mechanical to electrical. It's a very easy one. Please stick to that. Now we're going to look at the let's start with the AC generator. What is the word AC mean? The word AC means alternating current, which means with the word alternate, that means it's a generator that has a current that is alternating, which is that changes the direction, right? So the current here, it changes the direction every half a cycle. That's very important. So the current that is produced, guys, in the chemical in the generator, we're generating electricity. So there will be a current that will be what produced in the coil there through the movement. So if we're moving this handle here, we're twisting it, that means the coil is turning. So turning that coil, it causes the mechanical, that's the mechanical part. And then that mechanical, because this coil, guys, it's in the electric field, so we call this, it's a what, it's a coil. The coil, it's an electrical conductor, right? So moving this coil in the magnetic field here, in the magnetic field here, it generates what, the current, which is the EMF there, right? So guys, what is important here, we have two magnets. The magnetic field lines, they're going from north to south, right, all the time, right? And we have two rings here. These two rings, they called slip rings. These two rings, they call what, slip rings, right? The slip rings, guys, what do? They ensure ensures that the current changes the direction every half a cycle, right? They ensures the current changes the direction every half a cycle. So what is the half a cycle? So guys, this is a full cycle, which is a full rotation of the coil. So when the coil rotates fully, that means it's 360 degrees rotation. So every half a cycle is going to be what, 180. So it starts here at 0, and this is 90, and this is what, 180. So when the coil rotates the 180 degree cycle, so it means that the current is going to change the direction. So these two rings, guys, then shows that the current changes the direction every half a second. So this is an AC, guys. In an AC generator, the graph, this is the graph of the voltage that is produced by this. So this is going to be a 0 voltage that is produced, and then this is the maximum voltage that the generator produced, and then it goes back to 0, and then it goes back to negative maximum, which is this value that was produced there is positive, and this value is going to be negative, and then 0. So the voltage or the EMF that is induced there, it varies between 0 and the maximum and 0, and the maximum and 0, right? This is a full cycle, right, guys? This is a full cycle in terms of the current that is produced there. Now it says slip rings on a generator preserve the solenoid EMF rotation, right? Okay, let's look at this one, guys. Another thing that is important here, the generator, guys, it uses the right hand rule. It uses the right hand rule. So that right hand rule, we call it, it's a Fleming's right hand rule, right? Fleming's right hand rule, that's what we call that. This is what, is a thumb. The thumb, it represents the force. So if the coil, let's say it's rotating in this way, this side of the coil will move up. So the force, that's the force. The force is up. And if this side moves up, this side of the coil, the force is gonna go down there. Right? So this thumb is represented by the force. And in this line, this finger here, represented the magnetic field. The magnetic field is from what? North to south. So this finger must point to from north to south all the time. The direction is going to be what? To south. And then we have this finger. This finger here, the middle finger, represents the current. So it will represent the current that is moving here. Right, so we always take the sides of the what? Of the coil. So we're going to look at one side. What is the direction of the current? For example, this side. So if it moves from here to here, your finger must point in this direction. So from there to there. I'm gonna show you guys. So this is the graph, guys, of an AC. Once you see this graph, you must know it's an AC. Even the current, the graph of the current will be this way, right? Now let's look at the DC generator. The DC generator, how do you spot a DC generator? Guys, you see this AC generator, you see by these two rings. These two rings, they tell you that is what? Is an AC, this one. These two rings, they call their slip rings. But once you see this one ring that has a split there, do you see? This ring has a half and has a half there. So this ring, we call it, it's a what? It's a okay, let me write it. It's a split ring. It's a split ring. This ring it has a split. It's split into two. So if you look at this ring, it has a carbon brushes. They have carbon brushes. Even this one, they have carbon brushes. I'll talk about the functions later of that. Both they have. So if you see one ring, you must know it's a DC. What does the DC mean? DC means a direct current. The current doesn't change the direction. It has a one direction. But the function of this ring, it ensures that the current doesn't change the direction. As the function of this one, it makes sure that the current changes the direction every half a cycle. This one ensures that the current does not change the direction every half a cycle. And how do you spot that? This is a generator. Both of them. You see it is a generator if there's no battery here. If there's a load like this one, there's a component here, which is this is a voltmeter. This voltmeter, it means that it shows that this is a generator. There's an electricity that is generated, electricity that is produced. But if there was a battery here, it was going to mean that there is a motor. But I'm gonna do the motor in other video, right? So this one is there. It's going to be a load. Sometimes here they're going to connect any electrical appliance there, right? So this is the coil, and these are the magnets. If you can see, even the direction of the magnetic field lines is from north to south all the time. And then this coil rotates, right? Do you see even the rotation of that, right? Here the current, it moves here in the coil, doesn't change any direction every half a cycle. Once you see a graph like this will be a graph of voltage, or it can be a graph of the current, right? Because this, it generates the current and the voltage. So the graph, it will be above the x-axis. You see, this is the x-axis. The graph will be above the x-axis, and this graph, it shows one cycle. This is one cycle, one rotation, right? It's 0, 90, 180, 270, 360. 0, 90, 180, 270, 360, right? So it will be above the x-axis or below the x-axis, like that, right? Be careful when you draw this, guys. These lines, they only touch them here. They mustn't cross each other like that. And even the shape, it must be the same there. So this is a direct DC graph, and this is an AC graph. I hope I do make sense, guys. Both generators, the guys, they use the what? The right hand rule, the Flemings right hand rule. Very important. The generators, what they use the electromagnetic induction. The principle that they use, besides the right hand rule, they use the electromagnetic induction.